This is the setup that I will be using to machine the center line for the bearing caps and the split line for the crankshaft. It's all coming together in one shot. Now I could get fancy and use a sine plate and tilty tables and whatever other kind of big dollar equipment that hobbyists probably don't have, but to illustrate the concept here, I'm using 2 soft jaw blanks. That's all I'm going to use. This blank is sitting at 45 degrees in the vise, and the part is securely clamped to that. First part of this setup, you want to make sure that the top of that pin is 0, 0 at each journal location. It's not important that it runs true to the y-axis or anywhere else. You just want to see the top of that pin true as you sweep across with an indicator. All right, let's bring that indicator around. I'm going to put the 0 right towards the camera. It's coming right at you. Might be a little bit easier to see what's going on. Right, now by moving the pin across and underneath the indicator, look for the high spot on the pin. As soon as you see a high spot, just sit there. Forget about it. Forget about it. That's your new center of the universe. Just to be sure that nothing is moved when you're over the first journal position, do that again. 0 here. And back across to the other journal position. Check that one out. That one is a couple of tenths high, but you know what? A couple of tenths on it's a steam engine. Let's not worry about a couple of tenths. I would say that's pretty close. All right, now that it is flat, and here's a secret for you. And believe me, I just went through this, so I'm going to tell you, this is going to be very potentially a tedious thing to do. In order to get this pin to lay flat across the top of this part, this casting has to rotate. As it rotates, the pin realistically rotates with it and goes up and down. That's why I say the top is the most important first. Get the top to run 0 by rotating the casting on the plate. Unloosen those clamps, tap it as you need to, get it 0, 0. Once you've got it 0, 0, here's the second half. Boom, right there. Loosen the nuts on either side of the main vise and tap the vise until this pin is 0 with your y-axis. All right? Rotate the part to get it planar. Move the entire vise to get it 0, 0. Now this rod that you put in when it was sitting true to the crosshead slide and everything else, that rod is now true to your machine. Once you have the top of the pin flat and the linear relationship true to the y-axis by moving the vise, tram both sides of the pin and establish an X0 spot. Find the high spot on the pin as you raise and lower the indicator. Gentle sweep and look at the number. Reverse the indicator, do the exact same thing on the other side. Once you have a number that you like, zero everything out, remove the pin. Now sweep the 2 inner machine surfaces for a Y0 and you're ready to cut. When you have your 0 position, 0 the y-axis digital, and you are in the center of the world. You can begin cutting at this point. The first plane I'm going to be looking to establish will be the top of the 031 boss. That is not the center line of the pin. Okay? That's the very first surface I'm going to be looking to machine. And the way that is set up right now, this is what I'm looking at. This is the surface that I want to do. It's 031 above the center line of that pin. And since I know it's a 101 radius on the pin, from that surface to the top of the pin, 70 thousandths of an inch. I'm going to use a 70 thou gauge pin, lay it on that surface, and just keep sweeping both of them with an indicator as I go to get a good feel for where I'm at. I will visually line up the cutter to the top of the pin, and I know that I can go about 70 before I have to start to worry. So I will visually line up to the top of the pin, drop down 65, and then I will use a dial indicator to make that measurement. All right, 70 it is, let's go. Do not move the table up or down. Do not move the cutter up or down. Put an indicator on the spindle. Somehow, somewhere, I'm going to use my indicol to do this. And I'm going to zero out the top of the 070 pin and see what we have against the 203 pin I will put back in that V groove. Let's check it out. Okay, remember not to move the table, not to move the quill. Move only the indicator arm. Boy, that's rough with the camera right in your face. More so than you would think. Beautiful. Straight up zero is top of the pin. All right, that is our registration surface right there on top of the pin. I'm going to lay a 70 pin behind it. Right here. We're going to sweep across that, and whatever the indicator tells us will be the amount to come off of those two surfaces. I suspect it'll be pretty close. Just over 12. Double check your zero. I'm going to call it 12 exactly. I'm going to set my knee dial to 12 before 0. That way the center trough, that 31 deep, all I have to do is dial in 31. So I'm setting the dial on my knee at 88, which is 12 before 0. One more check. Gonna go with it. 12 it is. I'm going to trust the numbers. I'm going to raise the table about 30 thou. I'm going to start the 499 slot that will house the bearing caps. See how that goes. That is about as flush as you could possibly get. I am extremely pleased with that. Extremely pleased with that. For all practical purposes, this notch is done. I'm going to put the tapped holes in. That's just a matter of finding the locations based on the XY0, sweeping it across, popping them in. I don't think it's even worth filming. You've seen holes drilled and tapped 1,000 times. I will, however, move this end mill out of the way and do the final inspection for you so you can see how this all worked out. But I am absolutely pleased with that. Beauty. Let's get the indicators. Let's take a look at the final pocket. And I think I'll orient that so that you can see it better. Hang with me for just a second. There you go. Okay, with the math that we did with the 20, this is a 203. It's a 15/64, I believe. Nope. 13/64. It's just a 13/64 dowel pin. It did not use a gauge pin. 203, right there. Now this is a 101 gauge block, so technically the reading should be a little different. Not much, but it should be a 1/2 thousandth or so different. Let's see what it looks like. as expected. It's a half a thou under the zero. If it were a 1015 block, it would have been tangent to the top of the pin. The half a thou under is an absolute spot-on indication that that center line of that bore, that journal surface right there, is right on the middle where it should be. Verify the zero one more time. And let's check the 70 thousandths height of the end. It's about 5/10 thousandths of an inch under. It's about a 30.5 step on there. You know what? Close enough. Anytime you want to hit 5/10 on a casting for a model steam engine, that's one knocked out of the park. I'm going to tap some holes in this. The next setup will be the side bore. That's going to be fun. Stick around. After some drilling and some tapping, that particular end is done, with the exception of flipping it on its side and putting the 375 hole in it. This center line, this particular feature right here, is a very tricky feature to do. It's a feature that has to be referenced from a feature that hasn't been created yet, so it's a very difficult feature to just dive in and do it. Putting the V-notch in when you're doing the crosshead slide surfaces is a fantastic way to reference the center, and then come back at a later date and reference that imaginary center with indicators and blocks and pins, just like I demonstrated. There's you're going to get yourself in trouble if you lay out from any hard edge, scribe a line, figure out what you got, try to wing it. You're going to get yourself in trouble, and ultimately you're going to probably blow this 500 dimension right there. You know, like I said, it's only a model. If it's oversized, well, it's not to print and it wouldn't pass inspection. But if it functions, at the end of the day, that's all that matters. Consider doing that notch. It works out really well. And if I had to guess, I have not assembled this yet, I'm going to say that the inside surface here is going to be flush with the cap. And for visual, I want to see the front flush as well. So inside and front, I don't care about the outside. And I don't care about what I'm going to call the trailing or lower edge. But for the interruption of the crank, if there's any chance of anything going bang, kabang as it rotates, I would think you'd want a continuous surface right here. I don't know, but that's just what I'm thinking. Alright, that's it for now. Thank you for watching. Joel Pye, Advanced Innovations in Austin, Texas. I'm out.